Hello everyone, I hope you had a happy Thanksgiving if you celebrate Thanksgiving, and I'm sure you're watching this after Thanksgiving, or probably on Monday, or maybe even Tuesday. So today's lesson is about Introduction to Redox Reactions. Redox stands for Oxidation Reduction Reactions, which you'll see on the next slide. So let me make the slides full screen. So again, Redox stands for Oxidation Reduction Reactions. And they involve the transfer of electrons from one atom, from one atom to another, essentially, to another. So if we take a look here, we have zinc solid, and then zinc loses 2 electrons. So let me get my pen out. So this here, because it lost electrons, is an oxidation. So I always abbreviate oxidations OX. And then here we're gaining electrons. Here, copper plus 2 is gaining electrons to become solid copper. So this is a reduction since the copper ion gained electrons to become neutral. Okay. So unfortunately, here is another set of rules that you have to memorize. Fortunately, a lot of them you already know. They're just sort of going to be written more formally here. So the first rule is that, and I can't find my mouse. The first rule, there it is. So the first rule is that for an oxidation number, and why is the mouse being so difficult here? Okay. So pointer options, pen. All right. So the oxidation number for an atom by itself is always 0, and this is also true for things that are diatomics. So if we have Br plus 2, which is a diatomic, the oxidation state on each of those bromines is 0. For monoatomic ions that are in a compound, the oxidation state is given by the charge of the ion. So for example, all elements, when they form ions in group 1, will have a +1 oxidation state, unless they're not bonded to anything, and they'll be 0. And then all group 2 metals, and I'm always losing my pen, I don't know why, I'm so sick of technology failing. So all group 2 metals have a +2 oxidation state when they're bonded. So H has 2 possible oxidation states, +1 when bonded to nonmetals and -1 when bonded to a metal. So for oxygen, we're going to ignore rule 1 for now, and talk about rule 1 later. For now, we're going to assume that oxygen always has a -2 oxidation state. Fluorine always has a -1 oxidation state. And aluminum always has a +3 oxidation state. And the other thing that is important is that the sum of the oxidation numbers of all atoms in a neutral compound has to be 0. So if the compound is neutral, you add up all the oxidation states, the total charge must be 0. If you're looking at a polyatomic ion, the total charge of the oxidation numbers, when you add them all together, of the polyatomic ion must be equal to the charge of the polyatomic ion. And we're going to see this on the next slide. So this here wants us to assign, and I hope my pen works here, wants us to assign, and again it's not, and I'm going to get mad. Pointer options, pen. Okay. So, oxygen we've learned is always -2. And there are 3 of them. So so we have to multiply. That's a total charge of -6. And then for the total charge to be 0, because this is a neutral compound, you see no charge written. That means the oxidation state of sulfur has to be +6. Okay. Now, also one of the rules, if you go back to the rules, is that fluorine is always -1. And there are 4 of them, so the total oxidation states given by fluorine are -4. So therefore sulfur has to be +4 for the total charge to be 0. Okay, so now this one's a little bit more difficult. Let's do the ones that we know. We know that oxygen has to be -2. So then the total charge here is -14, because 7 times 2 is 14. And I said that and I lost my little pen again, so I'm going to have to do this. And so we said that when we were when hydrogen was with nonmetals, its total charge is +1, or when it's +1, and that's a total of positive 4. If we multiply those two together, and then if we add up these together, we get a total charge of minus 10. Because plus 2, plus 4, and minus 4 equal 10. Now we have to figure out what phosphorus is. We have 2 of them, and we need to cancel out the negative 10. So in order for that total charge to be 0, the charge on phosphorus has to be plus 5. Because 5 times 2 is 10, and then 10 plus negative 10 is 0. So phosphorus's oxidation state here is plus 5. Okay, now this is a polyatomic ion. And if you remember, the polyatomic ions are a little bit different in the fact that they have to be equal to the charge of their ion. The total charge here is minus 3. So we know, we've memorized, and for now, that oxygen is always minus 2. So the total charge here is minus 8. And we want the overall charge to be minus 3 for the polyatomic ion. So in order for that to be the case, the charge of phosphorus, or the oxidation state of phosphorus, here has to be plus 5. Alright, so here we have more neutral compounds. And I don't know if you want to pause the video. So I know that oxygen is minus 2. So the total charge here is minus 8. And I know that sodium is plus 1, because it's a group 1 metal. And if there's 2 of them, so the total charge is plus 2. So I add those two together, plus 2 and minus and 8. And I lost my pointer again, which is keeps on happening. That the total charge here is 6, if I could get the pointer to work. So minus 6 when you add those two together. And there's only one chromate, so to get that to cancel out, the charge of chromate, or the oxidation state of chromate, has to be plus 6. Okay, continuing on. So hydrogen here is plus 1. Remember, hydrogen is always plus 1 when it's with nonmetals. So the total charge here is plus 4. Because 1 times 4 is plus 4. And then, so now there are 2 of these. So we have to think what times 2 will get us to get this to cancel out. So we need negative 4. So the oxidation state here of nitrogen is negative 2. Because 2 times negative 2 is negative 4. And negative 4 adds to 0. So here we have, these two are very, very important. We're going to be doing something called a redox titration some point in the next 2 weeks. So again, we always know that oxygen is minus 2. So that's a total charge of minus 8. And we want the overall charge to be minus 1. So that means that the that Mn plus Mn has to have a charge of plus 7. Because when you add those together, you get the charge of the polyatomic ion, which is plus 1. And then for this polyatomic ion, which is dichromate, has a overall charge of minus 2. So, and this is the hardest one. So again, oxygen is minus 2. There are seven of them, so the total oxidation state from oxygen is minus 14. And now, to get it to be minus 2, chromate has to give a total charge. All the chromates have to give a total charge of 12. So the question is, what does the charge here have to be for the total charge to be 12, so that when these add together, they get minus 2. And the total charge here is, if each one is 6, 2 times 6 is 12, and 12 plus negative 14 is minus 2. So chromate's charge here is plus 6. So, hold on one second. So, we're going to take a look at redox reactions in more detail when we get back from break. But in a redox reaction, one atom is reduced and the other atom is oxidized. And then redox reactions are, examples of redox reactions that we've seen are single replacement reactions, combustion reactions, and then most decomposition and synthesis reactions. Redox reactions are never double replacement or acid and base reactions, which we've been dealing a lot with double replacement, which is really another word for precipitation reaction. And we've also been doing a lot of acid and base. So now we're going to be working with the ones that are on top. Okay, so this is going to be the last slide. I've decided that writing half reactions we'll wait. We're going to have live class on Wednesday. We'll figure out what time on Monday. So we have to figure out, in each case, what element in the reaction is being oxidized and what element is being reduced. And I'm actually going to skip the combustion of methane. I'm just going to do these because I'm going to run out of time and I want to keep this video short. So, again, we have to do the same thing that we did. We have to find the oxidation state of each element. So we know oxygen is -2, right? The total charge here is -6, and we want the overall charge to be -2, so then sulfur has to be +4. Okay, so once again, Mn, -2. So the total charge here, 4 minus 2 is 8. And we want the charge to be -1, so manganese has to be +7. And I lost my pen again. I don't know why that keeps on happening. It's very annoying. Okay. So here, again, oxygen is -2. And we want the total charge to be, so the overall charge is -8. And we want the overall charge to be -2, so this has to be +6. And then last but not least, we know the oxidation state here because it's given to us by an ion, so it's +2. So now we have to figure out what was oxidized and what was reduced. So an atom is reduced when its oxidation number decreases. So if you take a look, Mn was reduced. Okay, the reason why it was reduced, like I'm just going to write red. The reason why it was reduced is that its oxidation state went from +7 to +2. So Mn was reduced. Okay. And then sulfur went from +4 to +6. Its oxidation state had increased. So S, or sulfur, which that's not an S, sulfur was oxidized. And then when we get to class on Wednesday, Monday, I think it's actually going to be on Wednesday because Monday we're going to discuss the lab. I'll talk more about writing balanced equations. This equation is not balanced, and the redox reaction and balancing redox reactions gets a little bit more complicated. So again, this reaction here, we're going to skip the combustion of methane. So this is a diatomic. I told you that the first rule, that single elements are diatomics, the oxidation state of them is 0. Okay? Hydrogen is also 0. Because it's a diatomic. Now we have to figure out the charges on the compounds. I told you, or in the rules, okay, whenever hydrogen is by itself with a nonmetal, its charge is +1. The total charge here then is +3, so then nitrogen has to be -3. Sorry, -3 to cancel it out. Remember, we want to make it 0. So if this is +3 total, not -3. And then we see that nitrogen, okay, went from 0 to -3, so that is a reduction, or its oxidation state got negative. So this was reduced. And then hydrogen, which went from 0 to +1, was oxidized, or it lost electrons. So I always like to identify the element that is reduced first, because that's the easiest one, because that's the one where the oxidation state has decreased or become negative, like more negative. And then I find the one that was oxidized. In every redox reaction, an element has to be reduced, and an element has to be oxidized. So you guys are going to get a worksheet that goes over assigning oxidation states and identifying the element that is reduced and oxidized. And then Wednesday in class, we're going to go over balancing redox reactions. But I will see you guys on Monday or Wednesday, depending upon when you're watching this.